In this video, we're going to look at the cross product of a vector. Let's say we have vector A cross vector B. What this actually means is the answer is going to be a third vector that is perpendicular to both vector A and vector B. First, let's think about this in a 2D perspective. So in a plane, let's say this line represents vector A, and let's say this is vector B. There's no way for you to draw a third line in 2D that is perpendicular to both A and B. So what this tells us is that the cross product of two vectors is only defined in 3D or in space. And the second thing this tells us is that the product or the cross product of two vectors is always going to give you another vector. So how do we actually find the cross product of two vectors? Well, the process isn't so simple, but first, let's define vector A and vector B. Let's say vector A is a1i plus a2j plus a3k, and let's do the same for vector B. And the reason I'm doing it in component vector form is it's going to help us in the next step. So b3k. And now to find the cross product, we need to take these vector A and vector B and form a 3 by 3 matrix. So the way we're going to do that, we're going to first put in I, J, and K, and then put in their corresponding values. So for I, it's A1 and B1. For J, it's A2 and B2. And for K, it's A3 and B3. And now we need to find or turn this 3 by 3 matrix into a bunch of 2 by 2 matrices. And the way we do that is first, let's look at the case for I. We cross out the row and column for I, and we take these four numbers and form a 2 by 2 matrix with that. So this 2 by 2 matrix, taking these four numbers and putting them in here will give us A2, B2, A3, B3, and this will be multiplied by I. And then we're going to have to do the same thing for J next. So we cross out the column and the row, and we take these four numbers and form another 2 by 2 matrix. And this time for J, we do subtract, we do minus. So minus A1, B1, A3, B3, and J. And then finally, we're going to have to do the same thing for got to do the same thing for J or for K, sorry. So plus we cross out the column for K and we take the numbers and form 2 by 2 matrix A1 B1 A2 B2 K. And the way to find the determinant of a 2 by 2 matrix is to multiply this diagonal, take the product of this diagonal and subtract it by the product of this diagonal. So to help visualize that, let's look at I first. So the product of this diagonal is A2 times B3, and we subtract it by the product of this other diagonal, which is B2 A3, and then we multiply that by I, and we subtract, do the same thing, multiply this diagonal, A1 B3, subtract it by this diagonal, B1 and A3, or sorry, minus B1 A3, and then finally we do the same thing for here, and we'll get A1 B2 minus B1 A2. And finally, oh, and don't forget the K and the J here. And now with this right here, if we have vector A and B defined with actual numbers, you'll be able to find it. So let's say that vector A is 1i plus 2j plus 3k. Vector B is 3i plus 2j plus 1k. And now this is going to give us A2, which is 2 times B1, which is 1, minus 2 times 3i minus 1 times 1 minus 3 times 3j plus 1 times 2 minus 3 times 2k. And now simplify this. Get 2 minus 6 will be negative 4i. And then subtract by 1 minus 9, so be negative 8, so positive 8j. And then plus 2 minus 6 will be negative 4k. So the answer to A cross B is this, and if you want it in component form, it will be negative 4, 8, negative 4. Now, this is the first method of doing it, but if we go back to this step over here, you may notice that this is a general form for finding the cross product of two vectors. And we can just use this as a general formula. So first, let's turn this into component form to make it easier to understand. So this will be A2 B3 minus B2 A3, and then this here's minus, so we multiply this in, so it'll be the other way around. So this will be positive, this will be negative, so we get B1 A3 minus A1 B3, and then finally A1 B2 minus B1 A2, A1 B2 minus B1 A2. So this is our general formula, and to make it even easier to remember, one thing you can do is switch this, or I would switch this one, or switch these around so that A corresponds to A here and B will correspond to B here. So A2 B3, and we're gonna switch the order because it doesn't matter, so it'll be, instead of B2 A3, it'll be A3 B2. And now we do the same for the other one, so it'll be B3 A1 and A1 B2 minus A2 B1. And now this is a good general format, or actually this one we should switch it, both of them around one more time. It should be instead, it should be A3 B1 minus A1 B3. So now all the A's are in one column, all the B's are in another column. So now if we want to look at the same question where vector A was 1, 2, 3, and vector B was 3, 2, 1. Using this general formula, we would get A2 B3, which will be 2 times 1 minus A3 B2, which is 3 times 2, and then A3 B1, which is 3 times 3 minus 1 times 1, and then 1 times 2 minus 2 times 3 here. So now this will be 2 minus 6, this will be 9 minus 1, and this will be 2 minus 6. So as you can see, using these two methods, we both get the same answer. And if you want to choose to memorize the formula, then you should look at this. Or if you want to solve by looking at the determinant of the matrices, you can also do that. You can choose whichever method you find easier. You'll get the same answer.